When people write a computer program, what they're doing is creating a file called the source code. The source code is in a programming language which can be understood by humans, such as C++ or Visual Basic. This source code is then transformed by a compiler into a file called an executable, which can be understood by computers. When we run a computer program, we're running the executable file, which consists of a series of instructions encoded in ones and zeros. The computer will typically carry out the instructions in order, but there are some exceptions to this. For example, the program may enter a loop where the computer keeps repeating a set of instructions over and over again. One type of loop is called a while loop. Here, each time the program reaches the beginning of the loop, it checks whether or not a certain condition is true, and will repeat the loop while this condition is still true. If the condition is not true when the program reaches the beginning of the loop, then the program will exit the loop and continue with the rest of the program. Another example where a program will not execute all the instructions in order is when the program reaches an if statement. Here, the program will execute one set of instructions if the statement is true. But the program may execute another set of instructions if the statement is false. Yet another example where the program will not execute the instructions in order is when it reaches a call to a subroutine. Here, the computer will remember where it is in the program, but will jump to the subroutine, which consists of a different set of instructions. Once the instructions in the subroutine have been completed, the computer will then return to where it was in the program before the subroutine was called. One thing to keep in mind about subroutines is that variables defined inside a subroutine will typically not have any meaning outside of the subroutine. Also, a subroutine will typically not have access to variables defined outside the subroutine. In computer programming, equations have a very different meaning than equations in algebra. For example, in algebra, the following two equations mean the same thing. However, in programming, the computer will understand the first equation, but will give an error message if you attempt to write the second equation. In programming, this equation is a statement telling the computer to evaluate the value on the right side of the equal sign and place it into the variable on the left side of the equal sign. For example, here the program will take the value 5 and place it into the variable a. However, if you write the following statement, the program will not know what to do, since 5 is not a variable. Therefore, this statement will produce an error message. Here's another example where programming is different from algebra. Consider the following two statements. In algebra, the second statement is nonsense. However, let's consider these two statements from the perspective of computer programming. First, we execute the first statement, which evaluates the value on the right and places it into the variable on the left. Therefore, the first statement places the value of 5 into the variable a. Then, we execute the second statement, which will change the value in the variable a from its previous value into a new value. The program first evaluates the right side of the equal sign, using the previous value of a. The program then assigns the result to the new value of a. What this is saying is that the new value of a is equal to the previous value of a plus 1. We previously assigned the value 5 to the variable a. Therefore, the previous value of a plus 1 is equal to 5 plus 1, which is equal to 6. Therefore, the computer program sets the new value for the variable a to 6. Let's now consider a program consisting of the following 3 statements. The first statement sets the variable a to 5. The second statement sets the variable a to 6. The third statement is a new instruction we haven't yet discussed. This is a statement which, in many computer languages, takes the present value in the variable a and prints it on the computer monitor. Therefore, when we run this program, the value 6 will be displayed on the screen. Let's now combine this with what we've described previously and create a while loop. Here is a while loop in the programming language Python. The first statement sets the variable a to 5. The second statement places the program in a loop, which will keep repeating while a is less than 10 at the start of each loop. Since 5 is less than 10, we enter the loop. The statement a equals a plus 1 changes the value for the variable a from 5 to 6. The statement print a displays 6 on the computer monitor. We have now reached the end of the loop, and we are therefore taken back to the beginning, where we check if the present value for the variable a is less than 10. The present value for the variable a is equal to 6, which is less than 10. So we enter the loop again. The statement a equals a plus 1 changes the value for the variable a from 6 to 7. The statement print a displays 7 on the computer monitor. We've now reached the end of the loop, and we are therefore taken back to the beginning, where we check if the present value for the variable a is less than 10. In this way, we will keep repeating this loop several more times. Let's consider what happens on our 5th time around the loop. The statement a equals a plus 1 changes the value for the variable a from 9 to 10. The statement print a displays 10 on the computer monitor. We've now reached the end of the loop, and we are therefore taken back to the beginning, where we check if the present value for the variable a is less than 10. Since 10 is not less than 10, the computer program exits the loop and continues on with the rest of the program. When we run this program from the beginning, the following is what we will see displayed on the computer monitor. In the language Python, The lines of code inside the while loop are indicated by indentation. In Python, it's critical that all the lines inside the while loop are indented by exactly the same amount. By contrast, in other computer languages, the indentations are ignored and the lines of code inside the while loop are indicated by a statement indicating the end of a loop, such as the following example. Notice how for Python, you need the colon after the while statement, whereas in some other programming languages, the presence of a colon would give you an error. Here is how an if statement looks in Python. Here, if the value of the variable a is less than 10, the statements inside the if statement will be executed. But if the value of the variable a is not less than 10, then the statements inside the if statement will be skipped. Here is how the same statement appears in another programming language. Another difference between Python and many other programming languages is that in Python, you do not declare a variable before you use it. By contrast, in many programming languages, you will include a statement such as the following near the beginning of your program or near the beginning of your subroutine. This statement is letting the computer know that you will be using a variable called a, and that this variable will be an integer. Each programming language is different. It's not necessary to memorize the syntax for each programming language, as this is information you can look up each time you need it. This video is from the year 2025. It's only within the lifetime of people still alive today that electric computers were first invented. If you're a person watching this in the future, the information in this video may appear anachronistic to you, such as a video on how to program a computer with punch cards would appear to us. We've come from the invention of electric computers to the possible brink of sentient, self-aware artificial general intelligence in less than a human lifetime. But that is a topic for another video.